Hello. So today the topic is um, force component in net force. So when you have a force, right? I want to give an example here. Let's say you have a mass here or like an object, right? So this mass receive a force in this direction. So this is an applied force. So let's say this angle here, we're going to call this theta here, okay? So we're going to decompose this F into two components. So it'll be this way here. We're going to call that Fx, and that's equal to F cosine theta, right? And this one here, we're going to call that Fy. That's equal to F sine theta, right? So there's a name for it. We're going to call this Fx. We're going to call that X component, right? So the work component, X component of F, right? And Fy similarly. So Y component. Okay, so then if we want to compute the net force, right? Let's see, there's another force that's going this way here. I'm going to call this one F prime. And we're going to give some example here, right? So example, let's say F prime is equal to 10 Newton, okay? And let's say F is equal to 20 Newton. And let's say theta is equal to 30 degrees, okay? So then we know Fx will be equal to F cosine theta, and that's going to be F cosine theta here, which is 20 times cosine theta, which is 0.866, right? So this is cosine 30 degrees. It's equal to square root 3 divided by 2, right? So 1.732 divided by 2, okay? So we can calculate that, and that should give you a number like 17.3 Newton, okay? And then you have Fy is equal to 10, right? 10 Newton, okay? 10 Newton. So now your net force, so the net force will be in this direction, you have Fx minus F prime, which is equal to 17.3 minus 10, and is equal to 7.3 going to the east, right? Going to the east. And then you have this direction, the force in this direction, which is your Fy, and that's equal to 10, right? So that's Fy, which is equal to 10 Newton, right? And that's also Newton. So now you can see your net force. So the summation of forces here is equal to F, right, vector plus F prime vector, which is equal to F net. And it's a vector, okay? And this vector has the component of this one here, right? 7.3 in the x direction, and the y direction is 10. So this is going to be equal to square root of 7.3 square plus 10 square, and that's your magnitude. Okay, so you're going to go and compute it, and I'm not going to compute it. And the angle will be this one here, right? So we're going to redraw it here. We have 10 going this way, and we have 7.3. Oh, it's a little too long, okay? So I'm going to make 10 a little longer, okay? So then this angle is going to be right there. So you can compute this theta for the net, right? So I'm going to call that theta net, right? So this theta n, I'm going to change in color here again. So this theta n will be arctangent, and then this one here, right, which is the x component of the net, right, which is 7.3, right? This is 7.3 here, right? And then on the top here is going to be this one here, which is the 10. So that would be your theta n to describe this F net, okay? So this magnitude here, this is the magnitude of this one here is equal to this. So Fn is equal to this. You can compute this one. So 7.3, this is 10, right? So this one here, the magnitude is square root 10 squared plus 7.3 squared. Okay? So your magnitude, your directions, you're all done. So that's how you compute the net force, and that's how that's the definition of component in the x and y direction. All right? So obviously we have the y going this way and the x going this way. Okay, so I think that's enough for one lectures, and we're going to stop there. And so until next time, bye-bye.